Hey everyone, and welcome to today's explainer. We're going to dive into a super fun source today called The Great Toy Rescue, Push and Pull. It's got this awesome bouncy energy, and it introduces us to two fantastic characters. Pip the robot, who's got a whole lot of mechanical energy, and his buddy Sam, this super clever kid guide. Together, they're going to show us exactly how everyday forces actually work. So, picture this. Pip is trying to clean up the playroom, right? And he needs to move this absolutely giant toy box over to a shelf. But it is completely stuck. You can just imagine the frustration. He's pressing against it, he's squeezing it, making all these hilarious beep boop, noises. But his little robotic feet are just sliding uselessly backward on the floor. Despite all that effort, that heavy toy box is literally not going anywhere. Well, this is where Sam steps in to save the day. Sam tells Pip about the magic words of movement. Now, Pip, being a literal robot, starts whirring his gears, thinking he needs some kind of wizard's wand or actual magic spells. But nope, Sam tells him no wands are necessary. The secret isn't magic at all. It's actually just the fundamental forces of movement. It's all about physics, leverage, and, well, using your own body. Actually, let's try something really quick. Can you show me your hands? Go ahead, wiggle your fingers. Sam asks this exact same question because, you see, our own bodies are the best tools for understanding how this stuff works. Just by using our hands and arms, we can figure out exactly how things move and, more importantly, figure out the exact mechanics Pip needs to rescue that stubborn toy box. Okay, let's jump right into section 1, the secret of pushing or moving things away. So Sam starts with this first big concept, the push. Pip puts his metal hands on the side of that heavy toy box, winds up, and gives it a massive shove. And guess what? Zoom! The box flies across the floor. What Pip did here was apply a push. Basically, he used force to make an object move away from his body. It's this really cool spatial relationship where the energy you use actually creates distance between you and the thing you're touching. You actually do this all the time. Think about the everyday examples from our source. When you push open a heavy door to go outside, or when you're steering a grocery cart down the aisle. Pip's absolute favorite example, pushing those buttons that make goofy sound effects. Beep, boop, squeak. Every single one of those actions relies on that exact same kinetic force, pushing something away. But now we've got a new problem. Because Pip pushed that toy box with so much robotic enthusiasm, it zoomed all the way to the complete opposite side of the room. And Sam's like, wait, we actually need the box right back here where we are. Pip runs through his robot logic. Okay, if pushing sends things away, applying that same force again is literally just going to send the box further away, into the distance. Not helpful. Which brings us to section 2, the opposite secret, bringing things closer. So to solve this spatial dilemma, a push just isn't going to cut it. They have to do the exact opposite. Sam demonstrates this perfectly. He leans down, grabs the handle of that runaway toy box, and brings it right toward himself. And that is exactly what pulling is. It's applying force to bring an object closer to you. You're using your energy specifically to close the gap between you and the object. And just like before, Sam shares some super practical examples to help us visualize this. Whenever you grab a handle and pull open a drawer in the morning, that's a pull. Or think about being at the park and dragging a little wagon behind you. You are continuously applying force to bring that wagon along with you, keeping it nice and close. So it really all boils down to this one simple, fundamental rule. A push sends things away from you, while a pull brings things closer to you. It's like two sides of the same coin, and once that clicks, wow, the mechanics of movement suddenly make perfect sense. In the story, Pip literally claps his metal hands together when he figures it out, because understanding this means you hold the secret to moving just about anything. All right, let's get into section 3, the push and pull freeze game. Let's test it out. To really lock these concepts into Pip's memory, Sam introduces this awesome game, and we're going to play it too. It's the perfect way to move from just talking about theory to actually feeling it in our bodies. The rules are super simple. First, you listen for the action, either push or pull. Second, you pretend to move something really big and heavy. And third, you stop and freeze like a statue the second you hear the word freeze. So come on, get up on your feet, get those joints ready, and let's do this. Here we go. Action 1, The prompt is to pull a heavy rope of rescue gear across some thick, sticky mud. Pip is doing it in the story, pulling this imaginary rope inward. I want you to try it too. Bring that object closer to your center of gravity. Give it some big grunts. You can really feel the tension and the muscle engagement it takes to physically close the distance between you and that heavy mass, right? And freeze! Hold it right there. Haha, I love the funny pulling statue poses. By pausing the movement right here, the creators of the source do this incredibly clever thing. They isolate that exact moment of physical exertion. You really notice the posture, you're leaning backward, you've got a tight grip, and all your energy is directed inward. Okay, you can unfreeze now. Ready for round 2? Action 2. This time, the prompt is to push a giant boulder up a steep hill. Pip immediately shifts his posture. He extends his robotic arms way out and leans forward to push that massive imaginary rock away from his body. Give it a try. Notice how it perfectly contrasts with what we just did? The direction of the force totally changes how your body has to align itself. All right, freeze. Hold that pushing pose. Look at Pip in the story. He's actually wobbling a little bit while holding his stance, which is just a hilarious visual. But seriously, freezing in this outward extension really highlights the difference. By breaking down these actions like this, the source makes some pretty abstract physics concepts feel totally intuitive, because you can actually feel the science in your own body. And that brings us to the big aha moment. Pip realizes that absolutely everything moving across the floor is relying on these 2 simple actions. Movement is just a constant part of our world, and at its very core, it's entirely driven by just a bit of push and a bit of pull. Understanding that totally unlocks how our environment operates. So virtual high fives to Pip, Sam, and to all of you for figuring this out. As Pip gives that toy box one last super comedic shove and actually slips a little bit doing it, it leaves us with the perfect takeaway for this explainer. What will you push or pull today? Pay attention to the physics around you. When you open a door, move a chair, or grab your groceries, just ask yourself, what exactly am I pushing or pulling right now? Thanks so much for joining us for this explainer, and keep exploring those amazing everyday forces that drive our world.